Hello, and welcome to session GRC321. My name is Nachum Klein, and I'm a director in Salesforce's information security team. And I'm so excited to be here to share with you how Salesforce has increased the robustness of our applications and our resilience as we've moved to AWS. Salesforce is a publicly traded company, so please only make your purchasing decisions based on currently available features and functionality. Today, we're going to talk about a number of best practices at various different layers and levels. We strongly believe that in order to achieve a robust environment and set of services, it is imperative to address resilience and availability at every single layer. To that end, I'm going to start with a brief overview of why Salesforce cares so much about availability and resilience. We're going to go through the various layers of availability, and then we're going to summarize with all the best practices and suggestions that we've talked about in the hopes that you can take them away and apply them to your own environment. You can say that Salesforce has billions of reasons to care about availability and resilience, because as you can see the numbers highlighted in yellow, in the course of 24 hours in Salesforce, we transact billions and billions of events for our customers, each one of which is potentially a mission-critical event for them that they need to process. And ever so much more so when you consider that some of our customers are doing life and death use cases. For example, LanguageLine, who provides critical translation services to individuals who may be interacting with 911 operators or emergency room technicians and who don't speak English. It is imperative for us, therefore, to ensure that we are always on and always available for our customers to run their businesses. Today, I'm going to talk about the lessons that Salesforce has learned over the 24 plus years that we've been running our services in our first-party data centers, and how during the course of the Hyperforce journey, which is essentially our strategy to exit our first-party data centers and run all of our capabilities and clouds and features on top of public cloud. This has given us a watershed opportunity to take those lessons learned, re-architect and rebuild our applications, and deliver the applications in a much more robust manner. So today's conversation is going to focus on those lessons that we've learned and how we've applied them in AWS to increase the resilience and availability of our applications. And I'm going to start with the design aspects. We all know, of course, with availability that you don't want to have single points of failure. So you want to isolate your applications and services into separate fault domains, ensuring that every fault domain has everything you need in order to run all of your services. In AWS, that would be an availability zone as a great example of a fault domain. What is oftentimes subtle and sometimes missed is the fact that as you have services and layers of distributed services, it's very possible to have one low-level service that you haven't thought about that does not exist in one fault domain. And inevitably, when that happens, at some point, you've now introduced a single point of failure. So it's important, therefore, to look through your entire dependency tree to make sure that all of your dependencies are met separately in every single availability zone. And as we model availability, we like to look at the number of nines, which represents the percentage of availability, percentage of uptime. As we do that, at Salesforce, we've taken a rule of thumb because we understand that a particular service instance or component can never have more availability than its dependencies. We therefore have a rule of thumb that every dependency must have one more level of 9 of availability than the application that we are designing and developing. The result is, if you look at the lowest layer has a lot of 9s, which is really important because you have so many higher level applications and services that are depending on those lower level components. Where possible, we try to avoid coming to a complete stop, because failures are inevitable. But when they happen, what we try and do is degrade gracefully rather than coming to a complete stop. And there are a few approaches that we take. One approach is where we can identify opportunities to run asynchronously. We will decouple producers and consumers and allow them now to communicate through message queues, such as Amazon's SQS. Doing so Both gives us opportunities to scale because we can scale the producers separately from the consumers. But additionally, in the event that a subset of consumers goes down or a subset of producers goes down, we can still operate, although perhaps in a degraded fashion. So for us, this has been a significant approach towards ensuring that we don't fail completely. Another approach that we also take is leveraging caching. Caching is a nice way that we use to hide the fact that we may have an internal outage because we're still delivering data. It's important to think this through in your design, though, because not every use case can handle caching or can handle stale data. And you want to, of course, as you take on your caching approach, you want to make sure that your data doesn't become stale. So you really need to give some serious thought to your architecture as you're designing this. And lastly, on the design aspect, when we look at a new application, a new component that we're building, we come up with an error budget. And the error budget is essentially, what is the maximum amount of downtime that we're willing to allow or accept for this particular component or service instance? And based on that error budget now, we have an equation which essentially says the frequency of outages, as defined by mean time between failures, times the duration of an outage, as defined by time to restore, times the impact, which, if you've come to a complete stop, maybe 100%. If you've downgraded gracefully, maybe it's less than that, times the blast radius, which is an interesting one, the percentage of your consumers or customers who have been affected. You want to, so the product of all of these should be less than your error budget. And the goal then, as we look at this, is to reduce each one of these 4 items. On the blast radius, what we do in Salesforce is we have this concept of instances. So we've got NA128 for some customers, NA214, we've got hundreds of instances. Each one is essentially a separate fault domain. Thus, if one instance goes down, yes, those customers are affected. However, the rest of our customers continue to operate as normal. And continuing this thought of reducing these 4, and particularly the duration or time to restore, what we found to be significantly helpful is leveraging artificial intelligence and machine learning to do exactly that. And we use it in a number of different ways, starting with incident detection. So you can think of our services as emitting thousands and thousands of events on an ongoing basis. And now we've got a layer of artificial intelligence that is now determining, reading these, and coming up with a baseline of what normal looks like. And based on that normal now, as soon as it detects outlying events, it will then issue an alert saying that we now have an incident. So we can detect these incidents fairly quickly. More on that when we talk on monitoring. Based on that now, we have a number of tools that we use to do root cause analysis using natural language processing. So we'll run through our log files as well as histories of previous incidents and problems that have occurred and how we've resolved them. And then we can take a branched approach. On the one hand, we have a set and family of incidents that we have determined that we can actually do auto-remediation. And so AI will auto-remediate the incident. For another set or category where we haven't yet turned on the auto-remediation, we still have the capability, leveraging that natural language processing that we've done, to present the incident commander with a set of documentation that says, look, here's where this has happened in the past. Here's how we've addressed it in other scenarios. So that even where it's not being auto-remediated, nevertheless, we can shrink that time to restore significantly, leveraging the artificial intelligence. And the impact for us has been huge. So we are able to automatically detect 61% of incidents with a mean time of detection of less than 10 minutes. And we're able to auto-remediate a third of customer-facing incidents, and that is currently in less than 20 minutes, and our goal is to get that down to less than 10 minutes. So this is still a journey for us, but we're really excited with what we've seen thus far and what we've been able to do with AI and machine learning. A challenge that Salesforce has traditionally had in our first-party data centers has been this concept of mutation. It's known that Salesforce does releases 3 times a year. Every time we do a release, we have to take thousands of pieces of code, features and functions, and their associated configurations, and layer them on just right in a loving manner on existing hardware so that we're not breaking anything that's already running. Right? And all of these pieces have to interact just right. Most of the times, it works. But it's a numbers game. When there are failures, whenever you're mutating something existing, you always end up in an incomplete state, and it becomes exceedingly difficult to debug and figure out where you went wrong. As we've moved to AWS, we've taken a different approach because AWS gives us disposable infrastructure. And given that, we can make everything immutable or unchangeable. And so we start with infrastructure as code. We at Salesforce use Terraform templates, but you can easily, just the same manner, use CloudFormation templates to achieve the same goal. With the end result that we now have this cookie cutter approach that we can use to actually now deliver Salesforce in many new regions really quickly because we have this all in source code. So we take the infrastructure as code from our source control. We layer on that the operating system images, and then the application, and then the configuration, and we package that up nice and neat into one box, which is all immutable. Now, we can take that and test that in lower environments, and as we promote up into production, we can be absolutely certain that everything that we tested in the lower environments is exactly what's going into production. For us, this has given us a huge benefit in increasing the robustness of our deployment processes. Another challenge that we've had in our first-party data centers has been, historically over the years, our services have delivered different metrics, right, that are meaningful to them. But if you think about a large cloud-based company with thousands of service instances, it becomes significantly difficult to gain an understanding of the health of your environment when you have all these different metrics and a mishmash of metrics being reported. So as we've moved to AWS, we've moved towards consistency. And we've identified 5 key metrics that we require every service to deliver. We call them the READS metrics, where it's an acronym where the R, which is the second column here, or the third column, is essentially the request rate, which tells us opportunities to scale. The E is the error rate, combined with the first column, the availability, tells us about the health of the service instances. The D, duration or latency, again, opportunities to scale. And then we've got an interesting one, which is saturation, or the S, which is essentially on a service-by-service basis. Are you memory bound? What's your memory consumption? Are you compute bound? What's your CPU utilization? Again, opportunities to scale. So this gives us a really good understanding of our service health overall. But we didn't want to live in an ivory tower. We want to make sure that we're seeing the world through the eyes of our customers. And to that end, what we've been doing is, in addition to the consistent metrics that we've been delivering, we also have something we call critical user journeys, or CUJs, where you can think of a user journey as logging in, or creating a case, or creating any other record. So what we'll do is we will create synthetic transactions and inject those into our processing so that we can now measure how quickly the response comes back and the accuracy of that response, thus allowing us to get a better understanding of the health of the applications. So this combination of the consistent metrics along with the critical user journeys at the service level really gives us a holistic view of our service health. As we've moved to AWS, we've made a conscious effort to focus our delivery method on Amazon's EKS, or Elastic Kubernetes service. The reason, primarily, is because that allows Kubernetes to address the health of our services and components at the lowest level possible. Because we create health checks on a service-by-service basis that Kubernetes can now check for each container to detect whether it is healthy or not. And where it detects that the container instance is unhealthy, it replaces that container instance with a new image. Thus, at the lowest level, we are now introducing resilience. Now layer on top of that the fact that Kubernetes has this concept of scalability through ingress gateways, and on top of that, the load balancers. It gives us, that combination gives us a lot of scalability coupled with the resilience at the lowest level. One thing to consider as you use EKS is by default, and that's with any Kubernetes, as you deploy into Kubernetes, it will not automatically spread your containers across availability zones. Thus, it is really important to consider creating anti-affinity rules that will tell Kubernetes how to spread the worker instances so that you avoid that single point of failure and that all your services exist in every single fault domain. And you can see the results of that. One thing that we monitor very carefully in Salesforce is something called the APT, or the average page time, which we try to ensure always remains less than 300 milliseconds. So you can see that we're very consistent during the course of one day, even though on the top, in order to achieve that consistency, we are scaling up and down the replicas on EKS. And you can see these little needles here and there, which essentially represent this shows us, okay, it's time to scale up. So we'll scale up, and then the needle goes right back immediately down, which allows us to keep that level of consistency. As we've moved to AWS, we've borrowed a page from Netflix, which also on AWS has pioneered, which is this concept of chaos engineering, or introducing a chaos monkey into your environment, which is randomly pulling switches and pulling cables, turning things on and off, what monkeys do. And the thought is, if we can remain up in the face of all these random failures, then we're pretty good. So we think of these in terms of two buckets as we inject these failures into our environment. There's the hammer bucket, and then another bucket of types of changes or failures that I call the chisel bucket. You can think of the hammer bucket as the big ticket items, such as the loss of an availability zone. So that's very important to model, but what I would counsel you is as you model this, you want to make sure that you are working on a team-by-team basis. One week team A, the next week team B, because if you try and boil the ocean, you'll end up with a lot of noise and not a lot of actionable items. So team by team gives you the opportunity to create action items for each team. We happen to be using a chaos tool by SteadyBit. One thing that allows us to do is have concurrent failures, which for us has been significant because in our history and our experience, a lot of the failures that we get are the perfect storm. This happened in conjunction with that. Right? So for us, being able to model these concurrent failures has been very, very helpful. But don't just think about the hammer approach. Really important to also take the more subtle failures into account because those happen by far more often. So think about things like what happens when a service instance introduces a 45-second delay before responding? What does that do to the other services within your environment? Or DNS issues, the smaller issues which can nevertheless cause big problems. One thing that we've done is we have delivered this chaos engineering tool to our developers. For us, that has been a tremendous benefit. Our developers test this on their own, and that allows them to ensure that their component is pretty robust, so that by the time we come to the official big chaos engineering test, we're addressing things that we wouldn't have otherwise found in the lower layers. So for us, this has been a huge win. And then lastly, on the database side, Salesforce is hugely database-centric, and the database is inherently very difficult to make resilient because it can only be in one place in any given point in time. So in order to do that, we've done a number of different things. Firstly, starting with immutability, we've re-architected our database to have an immutable storage layer, which is cloud native and goes across availability zones. And on top of that, we have a caching layer, which makes it very quick for us now to fail over from one AZ to another. On the application server side, what we're doing is we've extended the database driver so that it knows how to discover where the current active database node is, so that in the event of failure, the applications are blissfully unaware. They continue to operate as normal, and they have no idea that anything has happened. So I'm going to take a brief pause here just in case you want to take a picture. These are the various suggested practices that we found have been very, very helpful. Thank you so much. I hope you've enjoyed this, and if you have, you may be interested in attending GRC321, which will be just in a few hours. And please, please fill out the session survey so that we can continue to make our talks even better for you. Thank you so much.